Hi, we're Mars Petcare. I'm Kirby here with George, and we're data engineers for the global Petcare Data and Analytics team within Mars. So Mars Petcare is made up of about 50 different brands, 85,000 associates, hitting over 55 countries, and really we just cover a wide range of pet care needs. So our talk today, we're just going to go a bit through what our data platform looks like, some of the reasons that we've chosen to go for a Databricks and Spark ETL solution, and Delta Lake as both an internal tool alongside that, as well as our output for our analysts. So our platform, we are building out a data lake, which is like a global lake with all of the brand's pet care data all put into this one place. So then you've got a consistent format, you've got a single location for all of these data assets, and that gives you that one source of truth which all of the analytics teams across all of these different brands can tap into and use together. And that also means you've got shared documentation on all of these data assets and collaboration across teams that just wasn't possible before when it was all managed individually by the brands. Some of the brands that we've got a series of vets like Banfield, Blue Pearl, VCA, and they're really fun because we get a lot of medical data. You get medical notes, diagnosis, things like that. So you really get a view on the health of the pets and the things that come out of checkups. And then we've got a lot of nutrition brands, Pedigree, Royal Canin, IAMS. So a lot of the time we can tell kind of what foods they're eating. You can combine some of the information from them together to then see how pet food is affecting their health. We've got some pet tech companies like Whistle, who do GPS trackers for dogs, and Wisdom Panel, who do genetic sampling. And then centres like Waltham, which is a pet science centre, and they're really heavily into the research around pet health and how to improve pet lives. So the landscape currently is our sources come from all of these different business units who operate as their own businesses. So they've got their own source systems, their own data sets, their own models, and that's all managed by them using whatever tools they have chosen and set up with, which means there's a really varied approach to data collection and the structure that they store that data in. And this massive diversity in data quality, data format, is quite difficult if you want to swap between them, because you have to then learn about all of these systems and have access to tap into them. So that's kind of the source that we're dealing with. So our ETL tool takes all of that and then standardizes certain fields. We have the same date format. We provide the data all in the exact same way for users on the analytics platform, so they don't have to deal with all of the disparity kind of from these source systems. And then on top of that, we also optimize these tables for analytical use at output rather than the kind of more operational format that the data's in.
Great, so let's dive into a little bit about our solution, how we've built this framework using Databricks and Spark. So to start with and give you some context to talk about our tech stack. So Mars have chosen to use Azure, so that's the platform we're on. This is great. We've got access to a lot of tools, and obviously this plays very nicely with Databricks. So the typical tool for general ETL on Azure, as some of you probably know, is ADF, Data Factory. This is great. This is a great tool. It's got a lot of features straight out of the box. And this is what we were originally using in our team as well. What we found over time, and linking back to the slide that Kirby was just talking about, was that since this data is controlled by the separate business units within Mars, and we kind of have to adhere to their schemas and their schema changes, their export capabilities, whether that's fully up to scratch or not, that we were adding a lot of custom logic in via Databricks notebooks into those ADF pipelines in order to handle these error cases and these changes and schema revolutions and everything like that. So we got to a point where we just looked at what our pipelining system was like and decided that we could just build this from the ground up. and have a much more scalable solution using the powerful tool we had at our disposal, which was Spark and Databricks. So then moving into Databricks, using that as our basis, we then had this ability to directly connect to all sorts of systems because of the built-in JDBC connectors and libraries that are packaged as part of the runtime. And on top of that, we had access to the entire open source library of Python, using mainly PySpark as our choice of language. We could access any open source Python library to kind of do some more clever stuff around automated parsing of unstructured data like CSVs or JSONs. It's also infinitely in inverted commas scalable. We can scale out with those clusters as wide as we want, depending on how much data we need to push through this system. And then finally, we're really integrating Delta Lake in our framework, both as the metadata config layer for the pipeline itself, but also as our output layer that we give to our analysts for running models and analyzing and producing output from the data. So here's a sort of high-level diagram of what our ETL framework looks like. It's called Kyte, so if I use that name, that's what I'm referring to. This is a typical run of a single flow of a single table through Kyte. So at the beginning, we have the source picking up the data using these connection templates. The way that we approach this is with sort of packaged up connectors that we can then reuse. So rather than a separate pipeline or specific code to connect to a specific data source, we have a connector for something like Azure Blob Storage, or a connector for database systems. And then we can reuse that connector with the metadata coming from those Delta Lake configs in order to pick up the data from the right place without having a bunch of excess repurposed code. So those Delta Lake as metadata configs are really useful then, because we can drive that entire pipeline using those as a source and not have to hard code any of those values into the actual pipeline itself. And then beyond that connection template step, the rest of the pipeline is then identical. And it doesn't matter if we picked up a flat CSV or if we picked up a structured table from a database, that the ETL framework within Spark that we've built is then identical for the rest of the pipeline. So that's what it looks like for a single table. But sometimes it may look a bit more like this, right? So as I was mentioning about scalability, we have the ability to massively parallelize this. And we're parallelizing this at both the kind of Spark level with the data transformations and the partitioning of the data as we go using Spark, but we're also parallelizing it at another level on the driver in order to run things, run separate sources at the same time and run separate tables at the same time as well. So using Spark and Databricks gives us that ability to make it as small or as big as we want. So now that we've got that framework and we've built that sort of framework in Databricks and in Spark, we can then go bigger than that and we can build on top of that. So using the Databricks API, we've managed to kind of make things a lot more user-friendly. And the first is this video that's playing on the screen here, which is our custom dashboard for our ETL framework. This is called Control. It's kind of a place for monitoring, creating jobs, checking the status of our data in the lake. And all of this is completely hinged on using the extensive Databricks API library. If anyone hasn't used it before, it's great. You can do just about anything you can do in the Databricks UI and on the web, probably even more, I would say. And it can enable things like this, where you can hook in to set runs off and receive data and view the config tables again. So it can allow us to build this kind of tool. And another really useful thing we use the Databricks API for is our testing. So being an Azure house, we're using Azure DevOps for our general source control and deployments. And we can tie in our testing of our Databricks pipeline directly into that, because we can use the Databricks API. And so by specifying what size clusters we need for certain tests, because we can know that in advance and know what size they need to run on. We can build these tests into automatic continuous integration pipelines, as well as deployment pipelines to just go off and call these runs and return a result directly into that. So then moving into a kind of specific part of the pipeline, just to understand how it works a little bit, and a little bit, so Delta Lake itself and Parquet, which it's built on, have a Schema Revolution capability, but we've kind of added on top of that a way where we configure it up so we have complete understanding of what Schema Revolutions are happening to the tables over time that we're dealing with. So this slide's just going to go through a little bit of detail around how we deal with that. So the day one, we've got this initial load. It's just, you know, a set of columns with a set of data types. We detect that as we data, and we store it in our Delta Lake config metadata as our ground truth. So day two rolls around. We get the same table for this next increment, and it's got another column, as we see here. So we compare this and we say, okay, that is the same schema, except we've got a new column. Now, we know that Delta Lake can handle this, and so we say that's absolutely fine. We make our ground truth this new schema with the extra column. Day three comes, and you can see that column one has now actually changed to an incompatible data type. We've gone from an integer to date time, and we can't reconcile that. So what happens here is that we compare this to our ground truth. It says, no, this isn't gonna work, and we can error out with the correct error at this point in the pipeline, so that we know what's gone wrong. We can then go back to the source and get this fixed, because clearly something's happened here. Day four rolls around, and again, we've dropped that new column that we had, but the schema kind of lines up. What's important here is that we're comparing to the ground truth from day two and not from day three, because we never put that in, because it never successfully processed. So we're allowing this Schema Revolution, which is typically a real troublesome part, and we're allowing it to be relatively lenient, and then utilizing the capability of Delta Lake to merge schema.
The way our pipelines are set up means there's a lot of dependencies between notebooks, and as a team, there's a lot of collaboration happening on this, as we've got kind of one source code for a single pipeline that runs hundreds of tables. Have to be a bit careful with dependencies and overlaps. So we've kind of set up our own workflow for using Git with Databricks notebooks, and that's built off of some open source code that I can put a link in the chat to this on. So we manage all of our build and release pipelines and all of our Git repositories through Azure DevOps, Git Integration, really easy to spin up. So we actually work in a really traditional Git workflow. We have a master branch and then you feature branch off, I think how a lot of teams work. But what we do is, rather than using the built-in link between Databricks and Azure DevOps, we have a middle step, which is we manage our Git kind of on our local machine, where you pull down the entire repository, so the entire project code, and then you can deploy that into your user workspace in Databricks and work there. So that lets you have a branch of the entire project rather than just a specific notebook, which I think works a bit better with Azure Data Factory compared to orchestrating through Databricks. So having this defined way of working on a whole project level means that when you have those dependencies between notebooks, it doesn't get mixed up. You can test them because you've got your own project going on. And it means checking in. There's a lot less issues with people having merge conflicts and overwrites. So really it just opens up the entire team being able to work on the same pipeline at the same time without breaking links in between.
So over these next couple of slides, I'll just explain a little bit more detail around how we're working with those Delta Lakes as our config metadata and our approach to doing that. So firstly, to talk about the benefits of using Delta Lake, we get the ACID transaction benefits, which means when we're doing concurrent writes, this is thread safe. And this is super important, as I mentioned in a previous slide, around how we're parallelizing that driver process in our pipeline. we need the safety of being able to concurrently write to that config at the same time across multiple threads. Once we have that safety, what this means is that rather than having to spread out our configs into different locations, maybe per source or per table, we can just have a single master config table. I mean, one per environment, but really there is a single master set of those configs and everything can interact with that one set. This is great because it means, you know, we all hope that things don't go wrong, but if they do, it's really easy to manually change. We don't have to go and dig out where that individual config is. We have a whole process built around changing the configs. And there's also initial setup in doing our pipeline, you know, adding a new source or adding tables where we need to manually change. And so having that one master set lets us just create a process for that rather than digging around in a complex nest of files. So we're basically getting that traditional benefit of a kind of database system. You know, we've got that ability to concurrently write and read and that ability to have a transaction log, but with zero extra infrastructure. So we don't have the complexity of spinning up a server, whether that's cloud or on-prem. It's just files on a lake with that metadata layer that lets us do this. And then another added benefit on top of that is that since we're using Databricks, we've got that really nice kind of interaction between Delta Lake and Databricks where we can really visibly see that metadata layer, you know, look at that transaction log directly, view the size of the files and everything like that. The other point then is versioning. Again, we hope that things don't mess up, but if they ever do, it's super easy to just use time travel on Delta Lake and revert back to an old version if something does go wrong, rather than, again, using the example of many files dotted around and you're overwriting those files over time because, you know, you can't merge as such. That's a lot harder to roll back on. So that's a really useful benefit. And also the benefit of being able to not necessarily roll back, but at least see and track those that transaction log, you know, who or what has caused the most recent write, merge, or append, and to be able to track changes like that. So this diagram is kind of a bit of a visual on our approach. We have this need to keep our configs sort of source controlled and the core data that lives inside those configs, even if it's just the schema of that config itself, but it may include the manually inputted data as well. We want that source controlled and we want that to be able to interact with as a human. So we actually have that in JSON, and that JSON contains the data for the table itself, but it also contains the deployment instructions on how those tables get deployed into the Delta Lake config metadata. So maybe that's just a simple overwrite, take what's in the JSON and overwrite the Delta Lake tables, but it might be a more complex merge where you only want to merge on certain columns and update certain other columns. So this JSON file is really easy to interact with as a person, and we're planning to surface that in our UI in the future. That gets pushed into Git through a PR, and then Git will go off on a pipeline to deploy that into the Delta Lake. So that goes and uses the Databricks API that I mentioned earlier to call this notebook, this script that is our config deployer. Now that script will run through, and on most runs and on the successful runs, it will run the overwrites, run the appends, run the merges into our actual Delta Lake config tables that the pipeline is interacting with. And at that point, we then need to go back to Git and update Git with that version of JSON. So there's kind of a double master system going on. What the point there is that whatever sits in the Delta Lake tables is mirrored by what's sitting in the JSON. So in cases where this doesn't work and the deployment fails for whatever reason, maybe an error in a human error in the JSON, or maybe, you know, having two columns with the same ID or something, it will fail. That deployment will revert those Delta Lake tables pre-deployment, as it were, and then also revert back Git to pre-deployment. So in this way, whichever happens, whether success or failure, the point is that we always end up with a mirroring between the JSON and the Delta Lake table. So this slide, just to give a bit of kind of in-depth detail, if anyone's interested. On the left is what the deployment part of that JSON file looks like. So at the very top, you can see a very simple overwrite for a key value table. And the kind of second half of that JSON shows what the more complex merge looks like. So it's defining those merge rules, which columns we're merging on and which columns we're updating. And all of that is then taken forward and deployed in the right way by the script. On the right-hand side, what we have is what a table definition looks like. So you can see that there the schema's laid out, the identity columns, and then just a dummy row to show what that would look like. You know, super human readable, really easy to understand, and really easy to add and change as well, without, you know, one-off updates happening to those Delta Lake tables. We're controlling it all in a source controlled manner by using JSON.
So George has just spoken about kind of Delta Lake and how that's good for our kind of back-end processes, but that's also what we choose to store the data as for the analysts to access and use. So that's our kind of endpoint of the actual data that flows through all of this pipelines. And we tried out a few different things, but found that with our user base, it was definitely the both easiest and quickest. Part of that comes from being able to optimize, and the kind of data we use, it's quite big. Definitely needs Spark to hit it. And by partitioning on kind of common filters like dates, you can then just skip chunks of that. And we Z order a lot as well by join keys, and the performance aid on that is noticeable. So what that means is when you're doing a project using this data, just a lot quicker to get through. You don't spend ages waiting for your queries to go, which is what used to happen on some of the more smaller SQL storage systems. We've also got that version data, which isn't only good for rolling back when stuff goes wrong our end, it's also good for analysts and researchers to use, because you can recreate projects that have already been done on the exact same data set. So where more traditional databases have been updated and you lose that history, all you have to do is say, I want to look at what it was a couple of months ago and read in that. It means you can then validate those models. You can do comparisons between what we had before and what we've got now. And yeah, being able to track that history sometimes when you're looking at specific use cases is really something that you just can't do on other systems. We've also found just being able to freeze a table that you're working on without writing out your own copy of it is very good. So saying, I'm starting a project, but I don't want the data to change underneath me as it gets updated. I will always start my project by reading it in as of version 6, and that is my project version. And then later you can take that away and run it on a more up-to-date data set without having counts change and stuff like that as you're going. So we found that's definitely an analytical bonus. And then having the metadata accessible and visible is also very good. Being able to see when a table was last updated, being able to see the partition columns very easily means that the optimizations we've applied are accessible and usable. You could say, what's this partitioned on? Okay, I'm going to filter by that specific date because that's the one that will speed it up and that other people have targeted as a reliable date column. So we surface some of our tables through the Hive metastore in Databricks using unmanaged tables, which again, if you just want to look at the data quick and do the exploration, all you do is click on the data tab, and then you've got an example, you've got the schema, and you've got all of that metadata, like the data types and update history there, which means if you're not sure which table you're looking at, it's quite easy to dig in and get a quick view on them all. So that's kind of how we surface everything to our users. But everything we do as quite an action team is kind of for the advantages that come out of the projects that get done. So I thought we'd just finish off with a few examples of the stuff that our data goes into. So I mentioned Waltham are a science institute, really heavy research stuff going on, statistical analysis, machine learning stuff. So they've actually built an AI tool which can predict kidney disease in cats up to 2 years before the like traditional tests that would be done in a vet. So this is called Renal Tech, and it's rolling out at the moment in the US through Banfield Vet Hospitals. And just being able to look at the amount of data that we have as a whole using Spark kind of opens up these kind of models, which can just really revolutionize how we diagnose pets and pick up on early signals of common diagnosis. We've also got the Pet Insight project, who are looking at pets' activity behavior from these GPS trackers and pairing it with health issues which are recorded in the vet medical notes. And that's another way to look at early detection of things. So the potential for it is you can pair up dogs' behavior at home, like how far they're running, kind of activity like that, paired with common diagnosis. Again, gives you just a much deeper insight into the pet's life, which means the diagnosis on the other end is just the more you can base that on, the more accurate you're likely to be. And then another one of the pet tech tools that we've got is the Wisdom Panel, which looks at the genetic health of dogs. So if you can take a sample through Banfield, for example, on their puppy plans, you can get a genetic sample done as part of just your pet's healthcare routine. It then means that before they have any chance of developing something, you can be aware of what the most likely issues for that exact breed are. So if you have a certain breed type that's likely to get diabetes, for example, that might be flagged to you to look out for the warning signs a lot earlier. And the earlier you catch stuff, the better it is for that pet. So really all of this data, the outcome is really building a better world for pets, and that's the platform that our team is building.
Thanks everyone for listening, and we'd like to open up the floor for any questions.